Hey everyone, thanks for watching my talk, Beyond Tools. A theme of this conference is democratizing security via open source. And I think probably when most of us hear that term open source, we think about software, right? Scripts, code, things you run on a computer. Open source software is great, of course, but open source can be about a lot more than just software. We can continue to democratize. And that's what I want to talk about today. I'm going to talk about taking the strategies of open source software development and then applying that to setting goals and building processes to get things done on a security team. But first, who am I? I'm Chris Moberly. I currently manage the red team at GitLab. I've been working in and around IT for about 25 years now. I started off answering phones at a help desk. I've been a sysadmin. I spent years lugging a tool bag around to data centers with a label printer and a bunch of cables. I've done architecture, I've done consulting, I've done training. I've even done a little bit of sales and partnership work. At some point there in my career, when I was in my late 30s, I was looking for a new direction. And since I was young, I've always been a hacker. Not necessarily a great hacker, but a hacker nonetheless. And I decided to pursue that professionally. Fast forward a few years, and here I am today talking to you all about using open source to succeed in red team. I live in Melbourne in Australia. I still love hacking. I've got a young son at home, a 5-year-old. So we're doing a bit of hacking together, but these days it's more focused on his favorite video games and making him do silly things. You can find me on LinkedIn by searching for my name. I also have the link here on the slide. If you think that there's anything I can help with, seriously, reach out. I would love to hear from you. I've got a couple ideas about things I could potentially help with here. Maybe you're looking to break into offensive security, something that I did and later in my life as well. Maybe you're building a red team at your own organization, looking for tips there. Also remote work. I have a lot of experience there, working remotely work, especially building processes for globally distributed teams to get things done asynchronously. So would love to chat about any of those things or anything else on your mind. Reach out. All right, so on to the agenda. I'll start with sharing a story of a red team operation that we did recently and how open source helped us along the way. I'll demo some open source tools that we have for processes and planning. And I'll talk about what I'm calling open source adjacent resources, which is basically leveraging DevOps functionality for things other than building software. And finally, I'll share some ideas on how you can get started adopting some of the things that we'll talk about today right away. Now, I work on a red team and I work at GitLab. So a lot of the examples that I give are going to be specific to that combo. But the ideas should be usable whether you're on a different type of team, maybe not even a security team, and for whatever platforms you use yourself. All right, so I'm going to start with a quick story about a red team operation we conducted recently. And I'm not going to focus so much on the hacking aspect or the technical details. Instead, I want to talk about the workflow and how that workflow was made possible with open source processes and strategies. All right, so I've broken the operation into some general stages here. When we're actually working on these internally, we get a bit more granular than this, but this will do for telling the story. So the preparation. This is where the bulk of our work is done in this first stage. It's where we're researching, we're planning, we're preparing to emulate an attack. The first thing that we did in this particular operation and all of our operations is to fork an open source project that contains process and planning templates. That really helps us guide through all of the stages of the operation. It also helps our team to stay on track, especially as we're working remotely and asynchronously. Going into this operation, we had the general idea of the type of adversary we wanted to emulate, but we needed to really get some specifics there. So we needed to understand their motivations, their capabilities, and the techniques that they would use in the wild. And this is where threat intelligence comes in. So you've probably heard the term OSINT before. That's open source intelligence. It comes in many forms. It could be something simple, like a security bug or a Twitter feed, or it could be something more structured, like an RSS feed that uses open data standards to deliver that intelligence data directly to your own platform. So we did that. We spent some time reading about recent attacks. We started to build up a profile. Once we had a pretty good understanding of the adversary that we wanted to emulate, we made some initial plans for what the attack flow would look like. And for that, we leveraged yet another open source resource. This one's MITRE ATT&CK, and MITRE ATT&CK helps us to, it provides a standard language to describe attack techniques. So armed with the plan, we did a quick review to make sure that everything was in line with our rules of engagement. Again, another open source resource, a document that we maintain and publish publicly ourselves as well. This particular plan involves setting up some infrastructure for hosting malware and for deploying our command and control agents. Here's an area where we can leverage some practices that are popular in the open source world. For example, we use Terraform to define our infrastructure as code and to deploy it automatically. And then on top of that, we also use CI pipelines to test our deployment and to make sure all the functionality there was working properly. After that, it was time to start hacking. I'm not going to go too deep into our toolkit there. I've got a couple little logos at the top here that show what we call our attack VM, which we use. We run that on top of our corporate laptops, and that helps us avoid the security scanning software that's there. Our attack VM, it's an Ubuntu virtual machine. We have some other tools on there. The very first tool that I always install in my attack VMs is PDTM. It's a ProjectDiscovery tools manager, and it helps you install a lot of things that we would use commonly, like Navido and Nuclei and HTTPX. A couple other open source logos there. We use the Mythic C2 platform in the majority of our operations, including this one here. And the agent that we use this time around was another open source agent for Mythic that was called Merlin. Now, our goal in this operation was to infect a developer machine with our C2 agent, with that Merlin agent, so that we could gain control of their laptop. What we did is we created a fake landing page, which was hosted, of course, on an open source static site builder. And it looked like the documentation and download page for a legitimate open source utility. We took the code from that utility and we repackaged it with our Merlin agent, essentially creating a Trojan horse. This is another area where we like leveraging open source, maybe a bit of a unique reason, but it's easy for us to modify and to repackage open source applications. So we've got our background application, we have our website, developer visits the website, they download the malware, and we're in. On to Escalate. Our red teaming is a bit different than a lot of traditional organizations out there. We don't have corporate networks, we don't have Windows machines, we don't have Active Directory. So after we've compromised the endpoint, we're mostly looking to move either into the cloud infrastructure or onto SaaS platforms. And we do that by finding and reusing credential data. So we look for API tokens, service account keys, OAuth credentials, things like that. Once you find something that looks like a credential, though, you have to know how to use it. And this leads us to another great example of using open source for something that's not software. So there's a cool repository called Key Hacks, and this is just like a central documentation resource of tons of different credential types and how to validate them and how to use them. So we're on the endpoint now. We've gathered some different credential types. We learned how to use them, we validated them, but we want to start using them at scale. So from here, we do the same thing that a developer would do. We leverage open source libraries to write some scripts to do it for us. In this particular case, we were also able to find some pre-built binaries from one of the open source target platforms that made interacting with the API using that credential data quick and easy. As we're moving through the machine, we're probably finding new ways to do things. Could be like evading the security software, could be leveraging the credentials, could be automating certain tasks, doing things that we know we'll probably need to do again in the future. As we're going, we take notes on these steps and we stash them in our knowledge base. And our knowledge base, again, uses another open source strategy, which is version control via Git. And that allows us to centrally manage it and to share it with all of our team members. Something that red teams always need to do is to maintain what we call operator logs. And operator logs are basically records of exactly what attack techniques we conducted, when we conducted them, and where we conducted them from, like our source IP address. Sometimes you can gather this data from like the machine-generated logs at the end of an operation, but it's really nice to keep track as you go manually as well, so that you can end up with something that makes sense and that has context and that's human readable. We found that commenting in issues, of course, we comment in issues on GitLab. We found it's a really nice way for us to track things. So it has a built-in timeline. It's got user attribution. It's got collaboration and all these things that you need. We even have some advanced functionality inside GitLab where you can take an issue in a comment thread and turn it into an incident and have it create an incident timeline, which looks really nice for a red team operator log. So that's a cool feature, and it's just another example of creative ways to use features that are related to open source software development, but instead for processes and getting things done. All right, impact. Eventually, we're going to get caught. Right? Getting caught it's the point of a red team operation. It's critical in every red team operation. We want to make sure that we're providing an opportunity to practice incident response and to trace an alert back to the initial compromise. We always document a plan when we're going into an operation, and that plan will include what type of alert we want to trigger if we achieve all our attacker objectives silently. So we can make plans like this because our SIM detections are code that live in a repository. They're not open to the world, but they're open to us internally. So we can go take a look at that, and we do have a general idea of the detection capabilities when we're going into an operation. This transparency internally, it allows us to design operations that'll push the limits of our detection capabilities, meaning that we can demonstrate blind spots and we can propose improvements. Now, not all companies are this transparent, even internally, and I think this is another lesson that we can learn from the open source world. Inside an organization, we're all on the same team and we're all working towards a common goal. So having that type of data available is really helpful for the team. All right, so we've got our plan on how to get caught on purpose, and sometimes it actually plays out that way. Our blue team is pretty sharp though, and they'll often see us before we see that. When that happens, an incident is open. That incident is a self-contained code repository with its own issue tracker and its own permissions. So this allows us to manage a security incident the same way that you'd manage an open source project with specific collaborators and tasks, timelines, and more. Onto the debrief. A big part of writing a report, which is part of the debrief, is coming up with some nice graphics and flowcharts. We use a tool from MITRE, an open source tool, of course, called Attack Flow, and that draws the flowcharts which show all the stages of the attack. It's open source, of course, but what might be even more interesting is that the files that it produces are based on an open standard. That means those files are machine readable. It means we can deploy automation to parse them, and we can import them into other tools. It's pretty cool doing it this way because it gives us a single source of truth for our attack flows. So we create just one, and then we take those files and we use CI pipelines to parse that data and to import it into other open source tools, but like Attack Navigator from MITRE as well. Also, we could import it into places like our own threat intelligence platform. The most important part here of our final report is the recommendations that we provide, and of course, ultimately the changes that those recommendations will eventually lead to. So just like you do in open source software development, each of our recommendations is an issue. They'll probably also eventually be associated with a merge request. And this allows us to follow our recommendations from the time we open it all the way through to remediation. We can collaborate, we can contribute along the way, and it's all linked together. And it's in the same location as the code or the documentation that's going to be used to eventually solve the problems. Right at the end here, there's another feedback loop that happens. We probably learned some lessons along the way, and we might circle back again to our initial open source planning repository, open a merge request there, and make some changes to those templates. All right, now let's dive a little deeper into open source for process and planning. In this section, I'll expand on a couple of my favorite resources. The first is our Red Team maturity model. We created this about 2 years after our team first started. That allowed us to reflect on where we've been, where we're at currently, and where we wanted to be in the future. Doing this gave us a really nice roadmap, and it gave us specific goals that we could work towards for the next 2 or 3 years. This exercise was hugely beneficial. It helped us when we had to make some tricky decisions. It helped us balance priorities, things like that. This, again, here, this maturity model, it's another example where we use tools that are related to open source software development, but to build processes instead of code. So let me actually show you what that looks like. So this is our Red Team maturity model, and we built it using an issue board on GitLab. You could use GitLab to do this, but of course there's other tools as well that have issue boards like Trello. We have the various maturity levels, and each of these items it's an individual state or behavior that we want to achieve. We used issue labels to show. For example, we have here one called maturity established. That means that we have achieved this state, or we're demonstrating this behavior, and we're going to continue doing so. We're probably improving and iterating as well, but it's sticking around. We have another label called maturity replaced, and that means that we achieved it at some point, but that something later in the maturity model actually replaced that item that's a bit further along. We have another label as well where something is in progress. There's not one shown on the screen here for that. But what's really cool about doing this inside an issue board is that I can click into any one of those behaviors or states that we have listed here, and it's an issue. And it has everything that an issue has. So it has a comment section. We can collaborate. We can link it to other issues or merge requests or things that prove that we have achieved this. So it's really nice, very collaborative. There's even some cool UI stuff in here, like you can drag things and reorder them around. You can quickly add things from that. So that's it. That's our maturity model on GitLab. The next one here, the Red Team issue templates. This one is really the foundation for almost everything we do on the Red Team. It's an open source project. It's public. You can find it and use it. But again, it's not software, and it doesn't contain code. So do a search, find this for yourself, Red Team issue templates, and let me show you how it works. All right, so here it is. When we start an operation, we create a fork of this project. We think of this project as almost like a Red Team operation in a box. We create a fork of it into a private area so that we can work on it privately, of course. So the way that it works here is there's some different files, like we have inside a report folder here. There's a template that we use for our final reports. But the bulk of the work is actually in issue templates. So if I come here into this project and I create a new issue, you can see under these description templates, I have one for each stage of how we define a Red Team operation. That's everything from brainstorming to logistics, adversary profiling, all the way through to emulating attacks and retrospective. When I click on one of these, it's going to fill in the text, and this is everything that needs to happen to complete this stage of the operation. Really nice for remote teams and asynchronous teams. Everyone knows what's being worked on, what needs to happen next, can collaborate asynchronously, allows things to be done very consistently using these templates. So highly recommend using a project like this with templates. You can use ours, of course, fork ours if you're doing Red Team operations. But anything that you're involved in, a template repository like this may come in very handy. All right. Now I want to talk about what I'm calling open source adjacent resources. So not necessarily open source code or information itself, but using the same DevOps tools and resources that are common in the open source world to do things other than building software. So the first one here is automation. There's so many reasons to automate things, right? Safety, consistency, repeatability. I'm sure you've probably heard of using CI/CD pipelines to automate the testing, the building, and deploying of software. On the red team at GitLab, we love pipelines. We like to find creative ways to use them. It's essentially compute connected to your code repositories that you can run when you want to. Right? So some of our favorite use cases here, scheduling attack tooling to build and then execute against a list of targets, automating reconnaissance and then saving the output of that reconnaissance to artifact files, running atomic red team tests, TTP replays, so being able to repeat very specific attack techniques to check whether or not they are detected, collaborating on purple team operations, testing and deploying our attack infrastructure. So that's our phishing sites, our redirectors, our command and control framework, and building malware with unique signatures is another fun one to see. One specific example that we have is a web screenshot tool. And we actually created a public version of this as well that you can find. The one that we have internally that we forked runs on a schedule inside a CI pipeline. The way that it works is first a script runs that lists out all our public IP addresses and our DNS names. Then it runs boot and HTTPX from ProjectDiscovery to enumerate web services on those targets. And then finally, it screenshots them all. And it automatically hosts a website with the results using the built-in GitLab Pages functionality. A really cool thing about doing automation this way is that everything's in one place. So the code, the scheduling, the artifacts, and even the web hosting all together. Another good example is knowledge sharing. Using Git with a centralized repository allows you to version control knowledge bases or write-ups or proof of concepts or blogs or whatever type of information you're interested in sharing. You can also combine that with static site builders like Hugo or Jekyll. They pair really nicely if you're trying to present that data maybe in a more structured manner. An example that we use a lot internally is a Git-backed Obsidian wiki. It gives us something really flexible on our desktops that we can use so we can easily access data and take notes when we're in the middle of an operation. Then we can use the version control, the Git, to submit changes back upstream to be shared across the team. We also use version control for the Obsidian config files so that everyone on the team can have a consistent experience in using the application. All right, so that was a bunch of examples of using open source tools and strategies to get things done. If you want to try some of these out, I've got 3 recommendations to start with. These are the things that had the biggest impact on our own team. Number 1, create a maturity model for your team. You can use something like an issue board. Make it as open as you can within your organization so everyone can be on the same page and you can share that information with other teams. Number 2, create a process template repository. Even if it only has one template, that's a start. So pick one thing that you do often and codify it. And number 3, start using CI pipelines. These things are so powerful and you can get really creative with them. So to get started, maybe choose a script that you run manually on a regular basis and put that on a CI schedule. That's it. Thanks for watching.